Welcome, Hornets. We're going to be taking a look at finding inverses in this section. So one of the things that we have to do is be able to find an inverse once we know that it has one. So after we've determined that a function is one-to-one, we then want to find out, well, what is that inverse? Our concepts that we're going to have to deal with are, well, once we have the new inverse, what is its new domain? And recognize that the range of the old function is now the domain of this inverse of that old function. And the domain of the old function is now the range of the new inverse function. This is because of our change in x and y. If I'm going to replace the x with y and the y with x, that reflection over y equals x, then lo and behold, we're just talking about a change in values. So what was domain becomes range, what was range becomes domain. Be aware, oftentimes with functions that are not one-to-one, we have to restrict the domain, and you saw that last year. Let's go ahead and take a look at finding the function. The inverse of a function that we already know is one-to-one. So we're going to take a look at this first function. I am letting you know it is one-to-one. It does have an inverse. Lo and behold, it has a radical in it. It also has a fraction. Now, these are the most difficult types of functions to find inverses of, but we're going to follow the exact same process and just use our algebra to simplify it to y equals. The first step is to change the f of x into a y. So I'm just going to do that first. I'm going to go y equals, and I have x over the square root of x squared plus 7. I'm now going to replace every x with a y and every y with an x. Now you can do it at the beginning or the end. I prefer to do it at the beginning because I tend to get confused. Notice if you know what your challenges are, use them and avoid them, okay? Use them to your advantage and avoid them when possible. So I now have my x's and y's flipped, but I need to get rid of that radical. To do that, I'm going to square both sides. X squared is now equal to y squared over y squared plus 7. Notice the radical is gone by squaring both sides. I can now cross multiply, and I'm going to multiply both sides by y squared plus 7. This will eliminate it from the denominator. These are now gone, and I want to distribute the x squared. So x squared y squared plus 7x squared is equal to y squared. Now, in order to solve for y, we have to have the y on the same side, so I have to have an x squared y squared minus y squared, and it only makes sense to move the 7x squared over. I now have two y squareds that can be factored out as a GCF. I'm going to divide both sides by the x squared plus 1, x squared minus 1. And now I have my y squared. Now, some people are going to want to take the square root right now, but you have to be careful. That numerator is currently a negative. We're not allowed to take square roots of negatives based upon the domain that we've already discussed. So we're going to have to move that negative to the denominator, and it will flip the denominator around so that we have 1 minus x squared. I can now take the square root and have y equals. And I have the square root of 7x over the square root of 1 minus x squared. Now, please be aware, we are still talking about a plus or minus. This has two parts to it, as we have a positive and we have a negative. It is still one-to-one, but there are two different pieces. Let's just take a quick look at that graph so that we can show you what we're talking about. When we are looking at this, we are putting our x in the numerator. We have the square root of x squared plus 7. And then I'm going to do a quick zoom 6 so that we can see it. Notice it continues to grow all the way through its cycle. So it is 1-to-1. It just grows very, very slowly. If I now put this in, notice I'm going to have a negative portion and a positive portion caused by that absolute value. And when we put our graph in, let's just go ahead and put that fraction. And so now I'm putting in the square root of 7 times x divided by the square root of 1 minus x squared. And I'm going to hit graph. And there it is. Now, please take note, the graph does not continue because the curve goes too vertical, and we cannot graph vertical lines. So it's important to recognize that this will continue going up infinitely, but it moves so fast that it looks vertical. Our calculator can't graph the vertical, and so it had to stop. You'll notice our inverse right through the inverse axis. We can put that inverse axis in if you'd like. Let's just go y equals x and see it. See how they are symmetric to the y equals x axis, just as we expect. This is identifying and finding inverses. Let's do one more, and then we're going to end. All right, and we're going to have you practice on your own by finding one and then answering the questions. So let's just take a look. We're going to have f of x equals x plus 2 over x. We know this is a reciprocal function, and reciprocal functions have inverses. They are 1-to-1. So we're going to start by having y equals x plus 2 over x. We're going to cross flip the values. So x equals y plus 2 over y. We're going to cross multiply. We're going to move the y over. We're going to factor out the y value so that we have only 1, and then divide. This is now my inverse. Now, if we're going to check it, let's go back to our graphing calculator. We're going to put in the original function. We're going to go to y equals. Let's put the original function in, our fraction. We have x plus 2. Our denominator is an x. We go to our second function, clear. We're now going to put this one in. This is our fraction, alpha y equals. We have a 2 in the numerator, and we have an x minus 1. Now, if I've done this correctly, we should see the graph and the inverse and our reflection through y equals x. Notice the points of intersection are sitting on the line y equals x, and we now can see clearly our inverses. These are inverses, they do what they're supposed to, and we could check by just looking at some points. All right, ladies and gentle folks, hornets, that has been finding inverses from a standard graph that has 1-to-1. Next, we'll be looking at finding inverses when we do not have 1-to-1 and have to restrict domain. Thank you.